So let's just start figuring out what the curl of f is equal to. So the curl of f is equal to, you could view it as the del operator crossed with our vector field f, which is equal to, we can write our components. So I'll do them in different colors. I, j, and k components. I, j, and k components. And then I need to write my del operator, or my partial operators, I guess I should call them. So the partial with respect to x, the partial with respect to y, partial with respect to z, and then I have to write the I, j, and k components of my vector field f. And I will do that in green, well, I'll do it in blue. And so we have p, which is a function of x, y, z, q, which is a function of x, y, and z, and then r, which is a function of x, y, and z. And so this is going to evaluate as, it's going to be I times, so blank out that column, that row. It's going to be the partial of r with respect to y, partial of r with respect to y, minus the partial of q with respect to z, minus the partial of q with respect to z. And then checkerboard pattern, minus j, make that hat a little bit better, minus j, and then times the partial of r with respect to x, partial of r with respect to x, minus the partial of p with respect to z, minus the partial of p with respect to z. And then finally, plus k, and that's going to be times the partial of x with, the partial of q with respect to x, partial of q with respect to x, minus the partial of p with respect to y, minus the partial of p with respect to y. So we figured out the curl of f, and I'll leave you there. I'm trying to make shorter videos now. And so in the next video, we have to figure out how to express ds, and then we'll just evaluate this entire operation. We'll take the dot product.